My garage, I've got a little consumer unit with a few RCDs on it. This is the old heavyweight, whatever it is, 15 amp cable coming in from the house, and then it's a bit untidy above there, isn't it? But one of these is a spur, and it's a 20 amp trip off to a double. Plenty of whatever there are fuses, should we say trips, so I can put the lathe onto one of them. But what you're going to do is see live this little lash up. So I've got the 3 phases in earth out of the motor. I found this piece of wire. I've no idea which order the phases have been wired in. So it's just connecting to extend that up to the inverter. So I've just got the 3 phases wired in up there. I've got the mains in wired there onto a flex, and the earth coming round, so the motor is earthed, and then just onto a plug top, which gives me a 13 amp fuse and means of disconnecting the lathe power quite easily without having a separate fused spur or going over to there. That can be changed, it can be wired in directly as a fused spur at some other time. And of course what I intend to do is get the screened 3-phase wire, take the motor off again, and then put that in to the terminal block on the motor and connect it from the terminal block on the motor up to the inverter. So are you ready for me to just see if things go up in smoke? You're going to see this live. So the motor is sitting there, nothing in the way of the pulley, nothing in the way of the wires. That's on the wall. I followed the same wiring procedure as before. You've got the earth, live and neutral, and it had the live wire into the RL1, whatever it's called, on there. Is that in focus? Let's get it in focus when we switch on. Right, so that's tripped everything. The house alarm is sounding. All the lights have gone off. So I'm going to have to go and reset that. There we are. That was live, showing what happened. Now have a lot of clocks and timers to reset in the house. That, I guess what that tells us, apart from the fact that there is perhaps a short somewhere. Yeah, RCD trip. It was either overcurrent or short, but I'm presuming it was a short. Therefore we'll have to have a look at that. But have RCDs in the system. If you're going to run anything like this, you definitely need to have something in your system which is going to trip out nicely, so that you can come back and sort it. I'm wondering if the current draw was going to be too much, but it shouldn't have drawn. It should just put power onto that. Anyway, let's have a look at what's going on. Putting a meter onto the 3 pins on the plug shows good, what should I say, open circuit on those. There's no short between live and neutral, or live and neutral and earth. So what I've done is I've just dropped the 3-phase wires to the motor out of there. There shouldn't be much connection between the 3 phases. I'm going to check that as well. Okay, I'm going to do it again. I've just disconnected the 3-phase outlets. Let's see what happens now. Okay. Well, there are 2 bits of protection on the circuit breakers. One is for a fault, i.e. if there's anything which is connecting a live, or I presume even neutral, down to ground, or down to any other metal, and then that would trip it. But the other protection is overload protection. That's if the current flowing between live and neutral is greater than it's not blown any fuses. And it's a 60 amp breaker, I think, back in the house where it was tripped. And this breaker here, 63 amp breaker. Let's just push to test. We'll push to test. Yeah, I've got 63 amp breaker, which is what came in here, and so if the 60 amp breaker in the house is yeah, the 60 amp would go before the 63, I presume, as if there's some sort of short circuit on it. So 20 amp there. No, I've got 20 amp trip. I'm going to have to think about this. That's a 20 amp trip. So if there's more than 20 amps, that would go. So I think it's too great a current to earth somewhere along the line. And that happens when you've got moisture. This has been stored in a damp garage. You can tell from the surface rust on the lathe. When you've got moisture on something, you get a leakage to earth, and a very small leakage of a few milliamps will trip the circuit. So that, and I can't measure that leakage easily with my meter because there isn't any high conductivity. What I've done is I've dropped the earth out. Remember that protective earth is to protect me from shocks coming off the lathe if there's any fault, which would connect live to the lathe so that it becomes a live chunk of metal. And the reason I pulled the protective earth out is just to test whether the issue is due to some leakage down to earth. Remember, there's nothing else connected on the outside side of this because I've disconnected it there. So let's see if taking out the protective earth helps with the problem. It has. The fan is running. The inverter has come on. And so what I'm going to have to do is bring some sort of fan heater in here and dry this thing out, because the likelihood is that there's some moisture in the electronics with it having been stored in a damp garage for a while that's causing there to be a leakage down to earth. But the first bit about this is the inverter has come on and it's saying, I think it's saying RD9, but I've not got the manual. Right, okay, there we are. A bit of testing done there. Let's see if I can now. I know what will happen as soon as I touch the earth in there. It will trip the earth leakage breaker. Maybe I need to go and read up something about earth leakage trips. Yeah, now that's interesting. I've turned the power off. Let me turn the power on again. That's the power on. Yeah, I didn't realise this about the thing. Okay, there may be a capacitor in there, because if I turn the power off, no power, fan's still running. And there we go. So it will run for about 30 seconds after the power's removed, with the cooling fan still on. It seems to be that often these devices have a filter, a mains filter, because they're generating, I mean this one, a discrete, proper screened cable, properly terminated to reduce the interference from the high frequency side. And if they've got a mains filter on the input side here, then the leakage through that mains filter is enough to trip your RCD. So one solution is to use them without an RCD, but don't want to do that. And then the alternative solution, if it works, is to have an isolation transformer between the mains and this, and then sort out the protection this side of the isolation transformer. And that's going to cost minimum of £100. Can't see any isolation, a bit, you know, because you're talking about quite a high current transformer. Just a one-to-one isolation transformer. A one-to-one transformer that will take a few amps, and it seems they're not cheap. I've had this fan heater on blowing just to reduce the humidity in here and warm it up. So I'm going to look out for now, see if I can find an isolation transformer and see what other options there are, because I do not want to remove the RCD or rewire so that there isn't an RCD. I have a dual rail consumer unit in the house, so there is one of the rails on there is just standard circuit breaker protection rather than RCD, and so I could run everything outside from that one, but I'd have to bypass this whole consumer unit, and I don't want to do that. I like having that nice protection that trips.